Okay, so what we are going to look at now are weather hazards. Okay, so we should be calling these atmospheric hazards if we want to sound very geographical and use correct terminology. Okay, and what we need to know is the different types of atmospheric hazards and something called a global atmospheric circulation model, which is fairly tricky, but I'm going to help you understand it. We need to know the formation of and factors needed for tropical storms to form, and students need to be aware of a case study, an example as well. So I'll show you the one that we use at my school, and I'm sure the students will have their own, and we need to know the impacts of that tropical storm and how they responded. So first of all, let's start with this tricky model. Stay with me, I'm going to help you understand it. Okay, I want to start at the equator. Okay, so the equator is the hottest place on Earth, and that's because the sun's insolation, okay, or sun's energy is most concentrated. Okay, the equator is not closer to the sun. We can't write that in our exams. It's because the sun's energy is more concentrated. Okay, and what happens? All this hot air starts to rise up. Hot air rises. Just think of a Chinese lantern or hot air balloon. As it does, it gets colder because every 100 meters we go up into the sky, air temperature decreases by 1 degree. So that's why we get snow in some places and not others, because they're higher up. So it hits that cold air and it cools and condenses to form clouds. So we get heavy convectional rainfall on the equator. If it's hot, sunny, and rainy, that's why we get these biomes, which are rainforests. Okay, so this all helps us understand why we get certain biomes where they're located. Okay, so where it rises, it then eventually moves over here and sinks. Okay, it sinks down. So this represents high pressure. Now, if you go to the beach on a really calm day and it's a bright blue sky, that's because high pressure is in place and it's literally pushing the sea down, making it really calm. Okay, what it also pushes down is air. So high pressure pushing down, that cold, dense air pushing down, stops warm air from rising. And if warm air can't rise, we can't get clouds, we can't get rain. So if you look along here, which is near the Tropic of Cancer, you're going to find a lot of deserts, like the Sahara Desert and the Arabian Desert here. Okay, so again, this is why we find deserts, and it's all due to this Hadley cell. Okay, the boundary here between the Hadley and the Ferrel cell. So again, the air sinks, it moves over here and it starts to rise up. Okay, so over here between the Ferrel and the polar cell, these cells are just large sort of convection currents of air moving around the globe. Okay, so here, this is kind of near where we live. We get rain for a lot of reasons in this country. One of them is because we are on the boundary of the Ferrel and polar cell, and just like at the equator, warm air is rising. If warm air can rise, we're going to get clouds, we're going to get rain. Okay, and then when it rises, it moves over here and then sinks at the poles. So again, we've got that cold, dense air pushing down over the Arctic, and the same in the southern hemisphere in Antarctica. And because of that, Antarctica is known as the largest desert in the world. Okay, it gets less than the magic number, which is 250 millimeters of precipitation a year, making it a desert. So if you get a pub quiz question when you're older, what's the largest desert in the world? It's not the Sahara, it is Antarctica. Okay, largest cold desert, largest desert. So that's it. That's the global atmospheric circulation model. Key things to take away: when warm air rises, we have low pressure. Okay, we get lots of rain. And when air sinks, it creates high pressure, stopping warm air from rising, and it's very, very dry. Rainforests, deserts, temperate forests where we live, okay, because we get rain, lots of rain. Okay, good. Hopefully you've got it. These are different types of atmospheric hazards, so students need to be aware of flooding, for example. We don't talk about earthquakes and volcanoes, they are tectonic hazards. We have droughts, where it's very hot and dry for long periods of time, extreme cold or blizzards, okay, tropical storms, and wildfires. So there's some good examples. And in this country, we get the odd heat wave, we get the odd sort of cold winter, beast from the east. We do get massive flooding, that's the biggest one we get in this country. We do get the odd tail end of a tropical storm, but not full-blown tropical storms. And we get sort of woodland fires and heath fires, not to the extremes that they get in places like California and Australia. Okay, here's an example question. Study figure 2, information about extreme weather in the UK in March 2018. This was the beast from the east. Let's move this out of the way. Suggests how extreme weather in the UK can have economic and social impacts. Use figure 2 and your own understanding. Okay, so straight away, I'd be getting students to kind of annotate this question. I'd be getting them to put a box around suggest, give me reasons for, underline the key focus like extreme weather, UK, economic, social, figure 2. So there's actually quite a lot to do here, but it's not a difficult question, really. It's quite nice. And then they should be thinking, right, 6 marks, 2 paragraphs. 6 marks, 2 paragraphs. So one on this, one on that. So they need to decide what the paragraph's about. And it kind of gives us this because it says economic and social impacts. So I personally, 100%, would do a paragraph on the economic impacts and a paragraph on social impacts. And again, we've got to use this figure, just like with COSE earlier. If we do not use the figure, we are massively capping the amount of marks we're going to get. The examiner is saying, here's a figure, I really want you to use it. Okay, so we might say what we can see in the photo. I can see lots of lorries, okay, lots of trucks that are carrying goods, most likely, in a traffic jam. This is going to have an economic impact because, you know, we can't get those goods to their suppliers. Here's a fact to back it up. Look, the killer freeze cost the UK £1 billion per day as transport routes are disrupted by snow and ice. Businesses and schools are forced to close. Again, we've got warnings up here. Red, danger to life, risk to life, major disruption to travel and power. Red warning. Okay, so we can link those two together. Economic is all about money. Social is about people, and they can coexist, because if it's a social impact or an economic impact, it could be both. Okay, so if I'm losing money because I'm not at work, I'm being affected, so it's social. I'm also losing money, so it's economic. Okay, and as long as they've got a paragraph on each of those, they are going to get full marks. Okay, and there's just a bigger version there. Tropical storms are called different things depending on where you are in the world. So a hurricane is what we would call it in England because they're formed in the Atlantic, which is our closest ocean, and generally they affect the USA and the Caribbean. If you are in Southeast Asia, like Thailand or Vietnam, or in Australia, and they're formed in the Indian Ocean, it's going to be called a cyclone. If you're in Australia, they like to call them willy willies, which is great. And if you're in the Pacific Ocean and places like the Philippines and Japan, you're going to get a typhoon. And these are big. Okay, these can be really, really powerful, which we'll look at a bit later. Just another example of a question. Describe the distribution of tropical storms. This means spread. Distribution means spread, how they spread out. Don't just tell me where they are. And again, use everything in this figure. Just 3 sentences maybe for 3 marks. Okay. Where do they occur? Generally between the tropics, very close to the Tropic of Cancer. We've got some in the Atlantic Ocean here. Okay, sorry, Pacific, my bad. Okay, Pacific Ocean there, just because the projection is different. There's the Atlantic we can talk about as well. It's all labelled, so use the labels. And then use this key. You know, where are our most powerful tropical storms? Well, are, you know, category 4 tropical storms where winds can get up to 210 kilometers per hour tend to be north of the equator in the Pacific Ocean. So that would definitely get me full marks, really using that figure clearly. This is what we need for tropical storms to form. Temperature needs to be really warm. That's the sea temperature, the ocean temperature. And that would be like walking into a bathtub, okay? 26, 27 degrees. That water also needs to be very, very deep. You're going to get a cluster of thunderstorms starting to form. You also need something called, keyword, the Coriolis effect, which is the spinning of the Earth, okay? And that needs to be just right. On the equator, it's not right. Just above and below, 5 to 15 degrees north and south of the equator make for perfect conditions for tropical storms to form. And it needs to be a calm day. If it's windy, all that warm air that rises off the ocean to start getting it going, it's just going to get blown away. Okay, so usually think of a really calm, hot day out in the Pacific Ocean, for example. The sea's really warm, that hot air starts to rise, and it all goes downhill from there. And this is how they're created. So we already know at the equator, the sun's energy or insolation is greatest, so that the oceans are really hot, 26, 27 degrees. That warm air, okay, heats the air above it and it starts to rise up. So there's this warm air rising that we talked about earlier, okay? That leaves behind an area of low pressure here. So if I was drawing this, I'd put an area of low pressure there. Okay, and wind is just air moving from high to low pressure. So these red arrows represent air filling the gaps of the low pressure. So the warm air rises off the sea, leaves an area of low pressure, so the wind swoops in. Okay, so you've got warm air starting to do this, swooping in. Okay, and again, as it rises up, it cools and condenses to form big sort of cumulonimbus cumulonimbus, okay, thunderclouds, okay. So that's what we're going to have up here. So there's that low pressure, the air's getting sucked in and the whole system starts to spin. So it comes up and it starts to spin. It comes up and in and it starts to spin. And it's spinning because of that Coriolis effect. If you're in the northern hemisphere, which the UK is, it's going to move anti-clockwise, okay, anti-clockwise. Oops. And in the middle, you're going to get the eye of the storm. Okay, this is where it's really calm. You've actually got some cold air sort of sinking back in. You haven't got that warm air rising around it. So that's called the eye of the storm. It's extremely calm. It's very bizarre. It could be really sort of windy around the edges. And then for like an hour, it could be really calm. And then the storm comes back over. The eye wall, which is the bit just surrounding the eye, that is where the winds are most powerful. Okay, eventually, if the storm moves over land, the friction between the land and the air will slow the storms down. And also the thing that gives the storm its power and energy is warm water. So if the water is not warm and there's no water because it's crossing land, it can't pick up any more moisture, the storm will start to die. But they do get quite far inland before that happens. But the further inland you are, generally the safer you are. Okay, so that's kind of it. So you just need to know where are the winds strongest in the eye wall, what's it like in the eye, which is really calm, and what happens when it crosses land. It slows down due to friction. It loses its energy because there's no more warm water fueling it. Oops. Finally, students need to be aware how climate change is affecting tropical storms. So naturally, if the world is getting warmer, there's going to be warmer ocean temperatures, which means tropical storms are occurring more frequently. They're generally named sort of a boy or a girl each year, and it's sort of letters of the alphabet. In the last couple of years, they've run out of letters because there's so many frequent tropical storms. They're going to become more powerful, so more category 4 and 5 tropical storms, and they're going to become more widely distributed, which means places that don't usually get them are going to start getting them. Like the UK, maybe one day in our life we'll get a full-blown tropical storm, especially because I live in the southwest. Yay. Okay, and finally, students need to know a case study. This one is Typhoon Haiyan. It's in the Philippines, and it was devastating. It was a massive Category 5 hurricane. They call it a superstorm. Killed 6,201 people, a million houses were destroyed, leaving, that should say actually 4.1 million people homeless. So actually 4 people in a house roughly. So 4 million people were left homeless because of this. It cost $12 billion worth of damage. Okay. We have primary and secondary effects. So primary, what happened straight away. Secondary, what happened as a result of the primary impacts. Okay. They need to know a couple from each here really. Immediate responses and long-term responses. What did they do straight away? They did evacuate some people, 800,000 people, but they're a poor country, a low-income country, which means they didn't have the technology at the time to accurately predict it. They knew there was a storm coming, but what they didn't know is that there was going to be a storm surge, which is where basically because of that low pressure, the sea lifts up. Please YouTube Typhoon Haiyan storm surge. It's incredible footage. It's like a tsunami. It just comes in at extreme power, massive, 10, 20 meter high waves. And that is the sea literally lifting up and coming in with the wind. Terrifying, and that's what killed most people. In the long term, they have created no-build zones so that you can't live too close to the coast in some places now because they've learnt from that storm surge, and they've built cyclone shelters as well. They've also replanted the marram groves because they act like a natural sea defence. So I'd be getting students to think about this. What's the most significant impact out of these and why? Biggest marks, guys, in all exams is for assessment and evaluation, okay? Assessment objective 3. So you've got to explain why these are bad, but also what do you think is the worst and why? What's going to have the biggest impact in the long term, okay? Socially, economically. Who would agree with you? Who would disagree? The fishermen, for example, are going to think that this is the most significant impact, that all these boats were damaged. They've lost their livelihoods. They're not going to be able to get money in and feed their families, okay? That's everything for this session. That's quite a long one, but there's so much good stuff there. So enjoy it, and we'll move on to our next session, okay, which is going to look at climate change.